Okay, we're taking a look at a geometric mean problem from Chapter 3. This is in the Chapter 3 assignment. So we're looking at annual revenue for Corning Supplies grew by 5.5%, 1.1%, negative 3.5%, negative 1.1%, and 1.8% from 2007 to 2011, respectively. So because you're talking about percentage growth, and sometimes that growth is negative, this is a geometric mean problem. You cannot simply take the arithmetic mean of these percents and get the correct value to show you what your overall growth would be over that period of time. So let's switch to the toolkit to do this quickly. And we're going to look at our geometric mean tab and simply type in those values. And based on the way this is set up, it's important to enter the mean as, or those growth rates, as real numbers, not as decimal equivalents. And I have to be careful with my data input, otherwise I will mess something up. I'm going to delete these extraneous values that don't imply. Double check my data. Okay, that's it. Now, we calculate the growth factor. 1 plus 0.01 times each growth value. So in effect, we convert this to a percent, a decimal percent equivalent, and we add 1 to it. That's our growth rate, our growth factor for each year. And that's the value that we use in our geometric mean calculation. Of course, be sure to adjust the extent of the array, because these values are no longer relevant, although I won't erase them. So this is our geometric mean, but this is not the growth rate. To get the growth rate, we have to take this value, subtract 1, and then convert that to a percent. I'll just convert it to a percent. I'll format it as a percent. So using the geometric mean built-in formula, looking at the array from C4 to C8 is where our data values lie. The geometric mean calculation is 1.007152. Now, this is not the mean growth rate. And I assume people had read the textbook, so they would know that you still need to take that value and subtract 1 from it in order to get the decimal representation of the growth rate, and then convert that to a percent. Again, your textbook likes to have you multiply it by 100 to convert it to a percent. I simply choose to format it as a percent in Excel to the number of decimal positions that they asked for. In this case, they asked for 4 decimal places, and they said don't round in the intermediate calculations. So it's 0.7152 is the answer. And if we go back to the problem and check our answer, that is in fact the correct answer.